We are back once again. The LeetCode grind continues. It is day 19 of LeetCode every day. Yesterday's video was praying to the LeetCode gods. Today we're done praying and we're gonna simply show up. I heard from a friend by the Buffest scientist on YouTube, the Huberman Lab podcast. The most efficient amount of learning time is apparently 90-minute sessions. So in the essence of aiming for more gains in a shorter amount of time, I usually do 20 minutes. Now I'm going to try and do an hour and a half, but we'll see. Maybe just on weekends. But Huberman Lab, the God King himself, says 90 minutes is the ideal learning efficiency time. That is what we're going to aim for. And also got some comments on the last video. Never mind, they're gone. Okay, they're back. From Shinthant, keep up the grind. The grind does not stop. Appreciate the support. Also, Kid, pain indeed. The pain, honestly, you get used to the pain. It honestly, once you get used to the torture, it honestly feels kind of good. There's probably something deep related to humans biologically with suffering and life motivation, but we need suffering to appreciate non-suffering. Maybe none of us need LeetCode suffering though. But got some problems queued up. 1 hour and 30 minutes. I'm gonna aim, as always, the minimum just to keep the habit going is 20 minutes. The goal today is 1 hour and 30. We'll see if we actually make it that far. But in regards to problems we did the last few days, finally fried add two numbers yesterday, and it was actually kind of rudimentary. Actually, once you learn it, it was kind of rudimentary. But actually, this problem fried me, so it is what it is. I tried LRU cache. This problem fried me as well. I didn't even know where to start on this problem. Now that I've read the solution, it makes sense. I don't think I could solve it. But in the future, I'll probably try this problem again. I read the solution today, so it feels weird to try and solve it. Or maybe that's what we're supposed to do. Read the solution, so I should try it since I read the solution. But I think the new pattern will be one maintenance, or what do you kind of want to break up the learning pattern, right? So there'd be maintenance. So there's three phases, right? So there's the cards that I do. These are the problems that I try to keep up with, and there's the problems that are aiming to be in maintenance. So in terms of a split of a ratio, maybe it should be something like 33% of the cards, 33% of my time would be doing cards, 33% of the time doing maintenance, like preventing the leaky bucket from leaking, and maybe the last 33 would be new problems. But I'm starting to think maybe exposure to new problems is probably pretty important, because it helps you, I don't know, I feel like there's something to the new problems that helps de-isolate information, because I learn a problem and it kind of gets siloed into an island in my head. But as I do new problems with it, the island starts to break apart, kind of like Pangea, and it kind of melts together into a more cohesive island of ideas. So what I used to do is was just all maintenance until there was no more maintenance to do. Now I think I'm going to try and do, I guess the ratio might be 2 cards, or maybe 2 or all the cards, honestly. And then the rest of the time would be either, basically I want to spend the general rules, I want to spend more time on the new problems. That being said, I read the solution for LRU cache. I feel like it'd be a good practice to implement it. So I got fried, but I just read the solution, so it feels a little ham-fisted. It feels kind of like I'm cheating. And we did add 2 numbers, so that one's already on the way. I think what's best to do is do this valid palindrome card. I'll do 1 random weighted, and then I'll go down the list for problems as usual. But yes, don't forget to join the Discord. It's called the Hyperbolic Coding Chamber. There are thousands of people joining every day, and we actually just got our 3rd member for the first time, so pretty hype. And then yeah, I'm just gonna jump into it. So we have valid palindrome. Goal is linear time with constant space. So the phrase, so we have function is palindrome, S, which is a string, and then we have a Boolean output. Is palindrome, S is a string. So a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, that's any character, alphanumeric would be 0 through 9 and all like A to Z. Non-alphanumeric means anything that's not that, so colons, commas, spaces. It should read the same forward and backwards. Alphanumeric characters include letters and numbers. Makes sense. Given a string S, return true if it is a palindrome or false otherwise. So if we have a man, a plan, a canal, colon, Panama, we have colons and spaces. They said turn all the uppercase to lowercase, so we'll do that in our heads. Get a little crunch. Remove all non-alphanumeric characters, so that's comma, space, colon, all these weird characters. And then, boom, it should be the same forward as it is backwards. In this case, it is true. So we can do this in linear time with constant space, right? If we were to, actually, let's take a look at all the example cases, because I have a bad habit of skipping those. So S equals race a car. If we lowercase this, it's already lowercase. Remove alphanumeric characters, there's two spaces. Is this forwards as it is backwards? It's not because of this A here. And a space, okay. So if you remove the alphanumeric space right here, right, then it should be true, right? Looks like our string always has at least one character in it, so we don't have to worry about handling that case. And S consists of only printable ASCII characters. Interesting. So we could solve this in linear time and constant space kind of by reusing the string reversal algorithm, and basically, or the array reversal algorithm. And it's just an algorithm where we have a pointer, two pointers, one at the front, one at the end of the array, in this case our string, iterating towards each other. Once they reach the center, they would be done, right? But in this case, we're gonna, in the array string reversal version, you would swap the characters. In this case, we're not gonna swap the characters, we're just gonna check them, right? So we can do string reversal, and so we just do let left equals 0, and we'll do let right equals s dot length minus 1. We'll do while left is less than right. And we probably want to do while left is less than or equal to right, because we probably do want to check if the character in the middle is the same. And then in the string reversal, you'd swap, right, based on these two pointers, and you'd have a progress step, right? Left is incrementing towards the center, right? Right incrementing towards the center, but by decrementing, so you do right minus equal 1. Additionally, we also have to, right, convert all uppercase letters into lowercase letters. Well, we'll skip that for now. And we have to remove non-alphanumeric characters. That's the biggest problem right now. So if we're gonna do this in constant space, it must mean that we are kind of gonna be doing this with the input string, right? So the way we can do this is we can just skip non-alphanumeric characters, right? Because if we're supposed to filter them out, we can just skip them and it should return the same exact thing. So imagine if we have S equals, let me just make sure I'm recording, okay. We have S equals a man, a plan, a canal, Panama, right? If we had left, which is going to be at index 0, which is this capital A here, and right, which is going to be at this lowercase a, we would be good, right? They both match to A, we'd go to the next indice for both. So left would be 1, and our right would be, you know, end of the array minus 2. So we'd be at M and space, right? But if we filter out the space, technically left should be at M here and they would match. So what we can do is we'll just skip I actually didn't start the timer. So I'm just gonna say we're at 1 hour and 25 minutes. So we'll just say while s sub left, actually the first thing we want to make sure, right, is that left still hasn't passed right yet, right? And we'll say if s sub left, right, and we can just create a function called isAlnum, right? And if it's not alphanumeric, then we're going to increment left plus 1. So you can make a function up here called isAlnum, and it's going to take a string, but it's really going to be a character, and we're going to return a boolean. What we're going to do is going to say return s.match, and we'll just use regex here, and we'll just say a to z, 0 through 9. You might wonder why we didn't do capital A to lowercase z's, because that actually does include alphanumeric characters. I mean, actually, that includes non-alphanumeric characters as well. So if you do A to Z as a regex, I think it does include space and colon, because the alphanumeric value for capital A to lowercase z, that range includes some non-alphanumeric characters. And I think match should return, or I guess you can always use test. Let's try test, because I never use test. And we'll return that. And then we'll duplicate this line, except we'll do it for right. And then our progress step for right is actually going to be minus equal. And so we're after these two while loops, we'll now be at a place where we can compare characters, and this is where we can handle the uppercase, lowercase portion. So say if s sub left dot to lowercase does not equal s sub right dot to lowercase, we're going to return false, right? Presumably, if we make it all the way out here, we can return true, right? Because it would be a palindrome. So let's test it with our example test cases. We have a man, a plan, a canal, Panama. Left would be 0, right would be s.length minus 1, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're just going to say end of the array minus 1 for the sake of the thing. So left would be less than, let's just say 20 in this case. So while left is less than right, so 0 is less than 20, and s.left is not alphanumeric. So A is alphanumeric, so we're going to skip this. And left 0 is less than 20, and s sub right is alphanumeric because it would be A, right? We'll skip this and we'll say A to lowercase and lowercase a to lowercase. Are they not the same? Well, they are. So we'll go to the next iteration. So left moves up forward once, right moves up forward once. And then from here, 1 is still less than 19, right? And we'll do 1 is less than 19, and is s sub left, which is 1, alphanumeric? Well, it's not actually, right? Because this would be a space character and it doesn't match any of the characters we put up here. So what do we want to do? Actually at a plus, because we want at least 1. And from here, we would actually skip the space, right, and increment once. You get up here to m, 3 or 2 is still less than 20, so we're still now we're alphanumeric, right? M is alphanumeric, so we're going to check if both m's to lowercase aren't the same. Well, they are the same. We're going to keep going. So this looks good in my head. This is a long test case to run. And let's just do this one for s. So s would be length of 1, left would be equal to 0, right would be equal to s dot length minus 1. So that would be 0. So while left is less than or equal to 0, so both are 0, so it'll run once. 0 is less than or equal to 0. Is space alphanumeric? No. So we do left plus equal 1, and we'd have left equal 1. So now 1 is not less than 0. So we end this, left will be 1. Left 1 is not less than 0, so we'd skip this. We do s sub left, which would be out of bounds actually. Dot 2 lowercase does not equal s sub right dot 2 lowercase, so yeah, that'd be out of bounds. Maybe we want to do nullish coalesce. I mean, safe navigation here. Or not too lower, actually. Probably here when we do s sub dot. We didn't need to do safe navigation before, so it could be that I'm doing less than or equal to. I think we're actually safer if we don't use equal to, and we don't have to use the safe navigation operator that not every language has. So now if we rerun it, we'd have 0 and 0, but space would be 0 would not be less than 0, so we'd return true, right? So that doesn't make much sense. You know, I think we actually do want equal. Yeah, I think that is actually. I remember a version of this where we didn't use null coalescing now, so that's interesting. But left is less than right, and we use null. We'll use a safe navigation operator, and I think we should be. I think for tests you have to do you have to create a regex object with the string and then do test. We'll just do match, and they should return null. But I guess we could cast it. So this seems to work. Let's try submitting it. Yeah, just literally the case we just talked about returns true. We could add another case here where if they pass each other, then we're just going to return false anyway, so we don't have to check. But since we're checking, if s sub left, which would be, so they'd both be at 0, this is going to run 0 left less than right, so 0 would be equal to 0, and space is not alphanumeric, so we increment it by 1. 1 is not less than 0, so now s sub left, which doesn't exist, which would be undefined, does not equal s sub right, 2 lowercase. So we must not, this must not be failing, because we should return false here. So we should be returning false here. Left plus right must equal 1. 2 lowercase s sub right. Safe navigation 2 lowercase. So if we have 2 lowercase, does the safe navigation give us null or undefined? I thought it was null. If I said undefined, maybe it doesn't matter. We'd have null, and then null safe navigation lowercase would be null does not equal s sub right to could add another case here where if left is greater than right, or oh no, not if left is greater, because it can pass it as well, so that actually wouldn't work. No, actually it can't pass it. That should be false. Left is greater than right. If our string has a length of 1, they both be equal to 0, so we would be getting in here, but our output is false. Oh, it's expected to be true. Wait a second, input. If you filter it out, it's expected to be true. So if we filter out the space, an empty string is supposed to be actually if it's an empty string, hold up, this makes no sense. The only way, I think I know how to fix this. You could fix this by not using equal. Because an empty string, if I remove the equal sign, then this passes, because the only reason this runs is because 0 is equal to 0. But why wouldn't you check the character in the center? You have to make sure that they match. For example, if I have something like ABBA, left would be equal to 0, right would be equal to 3 minus 1, which would be 2. 0 would be less than or equal to 2. It'd be alphanumeric. This would be alphanumeric. A 2 lowercase would be equal to right 2 lowercase, so we'd skip this. Left plus 1, which would be B, and right minus 1, which would be B. But we can't just skip that. They'd both be equal to 1 at this point. And if you remove the equal sign here, then you actually just skip it and return true. That is what is strange. If I remove the equal sign, maybe we'll fail on an earlier test case. So it passes. That makes no sense, actually. You know what? I want to try my own input. So I'm not seeing how ABBA passes. Well, ABBA technically, so we'd get to the middle. Oh, I see. If they're ever the same, we're checking if it's a palindrome. So if they ever reach the same indice, there's no point in checking it because it would be the same. It would mean that the string has an odd number of characters. Once it reaches if the strings are ever the same indice, it means that they have an odd number of indices. So if we had A, B, B, A, then we would stop once they pass each other, because the iteration where we would confirm if we had B and B, right? 2 lowercase on both would pass, then they'd pass each other. Left would be index 2 and right would be index 1. We would return true, but in the case where there's only an odd number of indices, if they start at the same pointer, then they're the same. Then when they reach the same indice, that's fine because we're checking if it's a palindrome. If it's the same indice, then presumably it's the same character, so it doesn't matter. That's makes sense, but still a little odd. So if we also had an empty string, index 0, I think it just so happened, that can technically count as a fail. I see what they're saying. I think this only makes sense because an empty string technically is the same forwards as it is backwards. I see what they're saying. So we'll take it, this would be linear time with constant space. So we have move zeros, function move zeros, we have an array of numbers, and we don't have to return anything because they want us to modify nums in place instead. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. So you have 0, 1, 0, 3, 12. You want us to move all the zeros to the end while maintaining a relative order. In the case of nums, with an with one number in it, we try to move zeros to the end and nothing happens. So the array always has at least one number in it, and the nums can be, looks like the max range of a 32-bit signed integer. Could you minimize a total number of operations done? So you could do this with the sliding window pattern, I believe, where you would keep track of the last zero index. If you keep track of the last zero index, when you run into a 1, you could swap it with the last zero index. So 1 would be go with the last zero indexes, and then so on and so forth. And you'd keep shuffling this band of zeros to the end of the array. So we'll do pseudocode first. We'll keep track of LZI. Iterate over nums if run into if num sub I non-zero, right? What do we want to do if it's non-zero? I'm going to swap I and LZI. So if we're keeping track of LZI, maybe we'll set it to 0. So LZI will start at 0. We're going to iterate over nums. Since we're iterating over nums, the first number is going to be 0. So if num sub I is non-zero, well, 0 is 0. Next iteration, so our right side is going to be 1, or I is going to be index 1 now, and I is non-zero, so we can swap 0 with 1. Now we're going to have, maybe we'll have is 1. If our input array was 0, 1, 0, 3, 12, and duplicate it, we'll now have 1 and 0. We'll have swapped it, right? And then our I is going to be 2 now, so we're going to be here. It's still 0, so we're going to go to the next. Oh, so this is why doing pseudocode is a good way to do it. I just noticed that once we get to this index 3, it'll be non-zero, and we'll swap I and LZI. But if we swap I and LZI, we're actually going to swap it with 1 again. So on each iteration, each time that we swap, right, we want to increment. We're going to want to increment LZI, right? Because if we didn't increment LZI, we'd swap 3 with this 1 here. I'll make this bigger. We'd swap 3 and this 1 here instead of 3 and this 0 here. So now when we get to 3, we can swap 3 and LZI, and we'll put 3 here and 0 here, and then we'll increment LZI again, because now the last 0 is going to be this 0. Then when we get to 12, which is non-zero, we'll swap 12 with 0 here, and then we'll have 12 here and 0 at the end. So we can remove these lines of code, and we'll just create LZI equals 0. We'll iterate over for let I equals 0. I is less than nums.length I plus plus. And then we'll just follow the pseudo code, right? So if num sub I equals non-zero, right? Then we want to swap I and LZI. To do that, we're going to need a temporary variable, since we'll save num sub I. Since we're saving num sub I, we're going to give it the value of num sub LZI. And then num sub LZI gets the value of temp, since we overwrote it with num sub LZI. Then we increment LZI plus equal 1. So we just ran it with this one, so we know it worked. Let's try it with nums. So LZI equals 0. and then I equals 0, I is less than nums.length. So nums.length is 1, so we're going to do one iteration. If num sub I does not equal 0, num sub I does equal 0, so we're not going to do anything. So let's try running it. So we're getting a garbage collection error. Okay, let's take a closer look. We have nums here. We're declaring a variable lzi. We're starting I equals 0 while I is less than nums.length. Yikes. I included a plus plus. I didn't even know that was possible. We'll do I plus plus if nums I is not equal 0, right? Swap I and lzi. Increment lzi. So that looks good. That looks cool. So that'll be linear time and constant space. So let's choose a problem from the top 100. We did try to do LERU cache yesterday, but right before I started recording this, I read the solution. So I'm going to skip it for now. We're going to do merge intervals. I've never done this problem before, I think. Yeah, I don't have any submissions yet. I'll make this smaller. So we have function merge. We have intervals, which looks like a matrix, and we're supposed to output a matrix. So given an array of intervals, or interval sub I equals start sub I and I, merge all overlapping intervals. Return an array. So we're merging all overlapping intervals. Return an array of the non-overlapping intervals. Return an array of the non-overlapping intervals that cover all the intervals in the input. So it doesn't make much sense. Maybe it makes sense in this example. So we have the intervals, where interval sub I equals start I sub end I. Okay, so this is an interval. So you want to start at I. So interval, you want us to start at index 1 going to 3. Merge all overlapping intervals and return an array of non-overlapping intervals. So I guess you want to just go from index 1 to index 3. So that'll be 2, 6, 8, 10, and 15, 18. And the solution to that is 1, 6. But I'm not seeing how that relates to the indices they mentioned earlier. Merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. X, so they returned 8, 10, 15, 18. Since intervals 1, 3 and 2, 6, since intervals 1, 3 and 2, 6 overlap, merge them into 1, 6. Right, but this said merge all overlapping intervals. Oh, so it's not that 1 and 3 represent indices in this matrix that we're supposed to overlap. It's literally that 1 and 3 represents a range of numbers. So 1, 3, merge these into 2, 6, and then 8, 10 merges with nothing, 15, 18 merges with nothing. But it says return an array of the non-overlapping intervals. How does 1, 6 not overlap? Cover all the intervals in the input. So we have 1, 4 and 4, 5. I guess they want us to merge this into 1, 5. Intervals 1, 4 and 4, 5 are considered overlapping. But there's always at least one interval, and interval's length always equals 2. They don't really tell us what to do in the case of multiple intervals. So like if we have 1, 3, 2, 6, and like 5, 10, do you merge all those into 1, 10? Doesn't really say. So we're supposed to merge these intervals. Interesting. Merge these intervals. Not a lot of, so maybe we'll have an output matrix. Or I guess it's not really, yeah, it technically is a no. We have 1, then we'd have an output. We would iterate over intervals. Maybe we could check if 1, so if intervals 1, 3 going to 2, 6. If we're going from 1, 3 to 2, 6, they want us to merge that into 1, 6. Maybe the key to that is making sure that the last interval's number is less than the current interval's second number. So that 3 is less than 6. That means you would merge it. So maybe you could iterate over intervals length. Iterating over intervals length, right? Maybe you would say we'll say if a previous interval exists, if previous interval exists, maybe we could have a start interval, right, that we would set equal start interval that we would set equal to, you know, whatever the current number is. So it'd be 1. If the previous interval exists, or let's skip this case for now. For iterating over intervals, then we want to check that, let's say 1 or 3 is less than 6. Does it always say that start is less than end? Okay, start is always less than or equal to end. Okay, that's perfect. So if 1 is less than, you have to make sure that 3 is less than 6. So if 3 is less than 6, then we can merge the interval. Maybe we don't have to stop there. So let's just say if I minus 1 interval sub 1 is less than, or let's just say if I really want to do this going forward, we could do if interval sub 1 is less than I plus 1 interval. If I interval is less than I plus 1 interval sub the second number, then maybe the end interval gets set to I plus 1 interval sub 1. End interval end interval, which would start maybe at 3, now get set to I plus 1 interval sub 1, so that would be 6 here. And maybe we just want to keep going, right? Maybe we just say Go to the next iteration and say, hey, is 6 less than 10? Yes, it is. Oh, that's why I guess they also want you, it has to overlap. So 2, 6, and 8, 10 don't overlap. There's too much unknown information here. So 1, 4, and 4, 5. So 1, 4, and 4, 5 technically overlap. So maybe it could be a so let's just say if I interval will have 2 cases, maybe this could be an else if. Duplicate this. Let's say if I interval sub 1 is less than I plus 1 interval sub 0, that seems to be fine. We'll just change the end interval equal to I plus 1 interval 0. So this is the case where 4 is less than, we'll say, we'll be careful here and do less than or equal to on both. If 4 is less than or equal to 4, then end interval equals 4. Right? But if they're not, if they haven't, additionally though, we don't want to stop there. Maybe we want to have it like this so they can both run, right? Because in the case of 4, 5, right, I interval sub 1 is, so right, so now we have an even better, we don't even want to use I interval plus 1. What we want to do is probably just use end interval, because end interval is 4. Okay, so we're getting somewhere here. End interval equals I plus 1, and maybe we only want if none of, if so that was because far, let's try running it. If start interval, so what do we want to start the interval and interval at? Maybe we'll just start at, there's always at least one interval. So maybe we'll just start at the first values in the array. So let's just say start interval equals interval 0, 0, and this would be interval 0, 1. So we'll start at 1, 3, right? Or let's just say in the case of example 2, 1, 4. So iterate over intervals length. So since we're doing less than or equal to, this actually won't change these at all, but we'll run it anyway. Start with 1 and 4. So if I interval sub 1, which would be 1, or we want to not use I interval here, we probably want to just use end interval. So end interval, which would be 4. If end interval is less than or equal to I plus 1 interval, and now I'm thinking maybe we don't even care about the second interval. We're just going to operate at whatever interval we're at. So if end interval is less than or equal to 1, I mean, if end interval, which would technically be 4, if end interval is less than or equal to I interval sub 0, so I interval sub 0 would be 1. That's not true, so because 4 is not less than 1. And if n interval, which is less than or equal to I interval sub 1, well, 4 is less than or equal to 4, so we'd set n interval equal to 4. Go to the next iteration. Is 4 less than or equal to 4? It is, so we'll set, n interval equal to 4 again. And we'll say, is n interval less than or equal to 5? It is. We have 1, 5. So we probably want to start at IDX1. And if we run this one more time, we could say if 4 is less than or equal to 4, it is, so it'd be 1 comma 4 and 4 comma 5. Excuse me. And if n interval is equal to n interval is less than or equal to 5, I is less than or n interval will be equal to 5. So we'd have two cases here. The question is whether or not which one to add it. So this should probably be an else if. It could be an else if, but in reverse order. So if the largest range we can create is 1 to 5, now it'd be perfect. But if the best range we can create is 1 to 4, then it is what it is. So in either of these cases, we could do output. We could push start interval, end interval to whichever, and then we'd have 1, 5. But now we have to restart our intervals, right? So after we just need more information about how the problem would work, but we don't have that. We're supposed to return 1, 6. So let's just say if we run it as now, we start at 1, 3, we go to the next interval. 3 would not be less, 3, the end interval, which is 3, would be less than or equal to interval sub 1, which would be 6. We could push 1 comma 6 onto the output, the tuple. On the next iteration, what do we want to do? In this case, maybe if the next case, we would set it equal I said less than, but I mean greater than. Oh no, no, less than is right. Maybe we don't need the equal sign. Yeah, I don't think we need the equal sign. In this case, when we set the next value equal to 8, 10, nothing would happen. So we want to push 8, 10 onto the array. Else push start ITV, end ITV. Else push start ITV, end ITV. So we push 8 and 10 onto the array of tuples, and then from here we'd go to the next one. Basically, we only want to push when we're done checking the intervals. How do we know when we're done though? So you might be able to fuse more than one interval. So maybe this is easier done with a while loop. Where instead of iterating over the intervals starting at index 1, we could do a while over intervals length, and the whiles over intervals length, we'd have an inner while over the intervals length, and we'll just keep going. We'll just keep going while we can merge intervals. So if we start this over with 1 comma 4 and 4, 5, our start interval equals 1 and 4. Right, we have an inner interval, right, while over the interval's length. So is 4 less than I sub 1? Yes, it is. And so we actually don't want to do anything here or here, we'll just push it outside of the start interval. We'll just push it on the outside, or just keep it on the outside of the while loop. And then we could do, you know, I plus equal 1 or something in here to keep going on the interval's length. So we go to the next number. There actually wouldn't be anything left. So if we do I plus 1, right? So we'd skip 1, 4, because nothing would really happen. Well, while over the interval's length, we'd be in the inner interval, starting at I plus 1. Starting at 1, so we'd be starting at interval 1, which would tend to be the second index while over the interval's length. So it's kind of the last iteration. We'd do our work in the first half of the if loop, right? Because 4 would be less than 5, and interval would be 5. So we'd go out here. We'd now be in the outer range. So we do I plus 1, right? Ideally, maybe it's out here. We delete this else, and we'll push the start interval and the end interval between 1 over 5. So that looks good. We'll go to the next one. So we have 1, 3 would be our start and interval. Start index 1, which would be 2, 6. Is 3 less than 6? It is, so end interval will be equal to 6. So we'd have 1, 6 for now. Right, and you would need an I. You would need an I plus 1 in here. So now we'd be at 2, 6. We do I plus 1. Now we're at 8. But 6. So then if we were at 1, 6. If n interval, so this first one we want to check is that if n interval is less than interval I, but also n interval is greater than I interval sub 0. So that is a, so then we do 6 is less than 10, but not greater than 8. We go to else if n intervals, right, which would be 6, is less than n interval sub 0. Or I mean, no, it should be greater than. Yeah, greater than. So now, if it was greater than 8, which it isn't, now we're going to do a break. We could do a break. If we do a break, because when does this while, and we'd be at, so we'd be at the else if. What do we want to do here? We do I plus 1, but we already failed this one, so maybe we only want to continue while it's working. So what's our case here while it's working? It kind of sounds like it should just be the ifs that are in here, because these are the same values, but you actually don't know which one to set it equal to. You could use 2 ternaries, but that gets a little iffy for pseudocode. Either way, once you realize you want to leave, what do you do? If you hit break, if we hit the break button, then we could push our current interval onto this output, push our current interval onto the output and set start interval and end interval to current interval values, right? And then we could keep going again. we do I plus 1, and then we check the while loop if 8 or 10 is somehow in between 15 and 8. It wouldn't be, so we'd push 8 and 10 onto the output, and then from there 15, 18, push 8 and 10 onto the output, do I plus 1, then from there you do 15, 18, we go up to the top, there'd be nothing more to do, so we'd push 15, 18, I plus 1, and loop would end. So in general, this kind of looks good, but this while loop up here is a little finicky. I think the while that's supposed to be in here is actually these two cases, and the end interval will depend on that value. So do while over the while end interval is less than or, and we'll just put the other one that was already here there. Then n interval equals I interval. N interval, ternary, I interval 0 or 1. So it's kind of nutty. It is what it is. And if it's good, then you want to do I plus 1 and keep going. And if it's not, so I'll run it one last time and then we'll write the code for it. So intervals I, 4, 4, 5. So our starting intervals are going to be 1, 4. So while over the intervals length starting at 1, we're going to start at 4, 5. While n interval while n interval, which is 4, is less than I interval 1, which is 5. I think we do want less than or equal here. So 4 is less than 5 or equal to it, but it doesn't matter if it's equal to it. Let's keep it less than for now. So while 4 is less than 5 and intervals and interval is greater than, right, so we definitely do equal here, equal to the first one, right? So while 4 is greater than 5 or equal to the first interval, which is 4, right? Or n interval, which is 4, is greater than I interval sub 1. We don't have to worry about that case. So it would be true, n interval is going to equal to 5 here, and then we're going to do I plus 1. We're technically going to be out of bounds, so we have to say while in bounds. And then we push 1, 5 and set start n interval to current if it exists. If it exists, and then we would do do we need another I plus 1? Yeah, so we'd be double out of bounds, but it'd be fine. We'd exit, return output. So for those that's like example 2 looks good. Let's try 1, 3. We start at 1, 3, which will start in n intervals, and then we start at index 1, which would be the second index, which would be 2, 6. So while in bounds and interval, so in end interval, which would be 3, is less than I interval sub 1. So while 3 is less than 6 and 3 is greater than or equal to 2, which it is, our n interval is going to be 6. We're going to do I plus 1. We're now going to be at 8, 10. We're still in bounds, but is 6 between 8 and 10? It's not, so we're going to push 1 to 6 onto the output. We're going to set start and end interval to 8 and 10 respectively, since they exist. And then we're going to do I plus equal 1. Now, is 8 Is 10 in between 15 and 18? It's not. So we're gonna push. Is 10 in between 15 and 18? It's not. So we're gonna push it on. Right, we have start interval and end interval. Dang it, I messed up. I lost count of the variables. We start at 1, 3. 3 would be in between 2 and 6. So we start at index 1. Right, interval is going to equal to 6. So now we're actually going to be at 8 and 10. Right, but we stop because 8 and 10 isn't in the it doesn't pass the test. So we're technically at index 2. We're going to push 2. We're going to push 1 to 6 onto the output and set start and end interval to 8 and 10. We're going to do I plus equals 1. So now we're at index 3. So you're at index 3, and then 8 and 10 is 9 between 15 and 18. So we're going to exit out of the while loop. Oh my god, I keep getting lost in loops here. We're going to push it, start interval and end interval onto the array. We at index 3, you said start and end interval to current if it exists. Oh my god, I'm going to try one more time. Start interval. I usually don't try and keep it, don't try to write the variables down. I try to keep it in my head so that I can play around with it faster. I also think it builds a good habit of being able to do it all together. So output is an empty array, start interval and end interval equal 1 and 3. We're going to start at index 1 in the intervals array, which is going to be 2, 6. We're going to be inbounds, and 3 is between 2 and 6. Since that is the case, we're going to set our end interval equal to 6. We're at index 1 currently. Then we're going to do I plus 1, and now we're going to be at index 2. 1, 6 is not in the bounds of 8 and 10. So we're going to push 1, 6 onto the output, and we're going to make 8 and 10 our start and end now. And we're going to do I plus equals 1. Now we're going to be at 15, 18 with 8 and 10 as a start and end. We're inbounds. We're inbounds, and 8 and 10 is not between 15 and 18. So we're going to push start interval and end interval. We're not going to be in bounds between 15 and 18, so we're going to be out. So if we push start interval and end interval, we're going to push 8 and 10 twice. Maybe I'll probably just write the code. So const output equals an array. We'll have let start ITV. It's going to be intervals sub 0, sub 1, end interval, and then we're gonna let I equals 1, and we're gonna say while I is less than intervals dot length. And we're going to say while we're in bounds, so while I is less intervals dot length, and end interval is less than, and we'll just destructure where we currently are. We'll just say cur ITV I'll say ITV0 and ITV1 equal intervals sub I. So if end interval is less than ITV1, right, and end interval is greater than or equal to ITV0, or end interval is simply just greater than end ITV sub 0, I'm going to make this slightly smaller, then we just want to do what we said we would do. So end interval will be equal to, we're just going to ternary this. If that's the case, then it gets the value of ITV0. Other case, it gets the value of ITV0. And then here we'll just do I plus equal 1. And then we'll do output dot push this tuple of start ITV and ITV. Start ITV equals ITV0. End interval equals ITV1. Actually, so we said start if to current if it exists. So we'll make sure that I is less than intervals dot length. If that's true, then these values should exist. And then I'll just uncomment this, and we'll see what we get when we click run. But at this point, I just can't keep it in my head. This is line 16. So my output here is 1, 2. It's 1, 2. I kind of feel like that means that this should be swapped and this should be swapped. I'm still getting 1, 2. So I'm just, now that we wrote the pseudocode, I'm just going to this code is sort of wrong. It should be and this or this. So we have, if this is good and this, so the cases are on. I'm just going to delete all the pseudocode now because this is impossible to read. Okay, so while I is less than intervals dot length, we're going to destructure those values out. I starts at 1. I'm going to try it for a smaller case. I should be able to change the input. So my answer here is 1, 4. And I think it might be because I swapped these earlier. So algorithm is not completely botched. It does technically work. Intuition is kind of there. Let's try a smaller version with just 2 and 6. So this works. It seems to be when we have more, like 8 and 10. So in this case, I only return 1, 2, which makes no sense. So start interval equals 1, and interval equals 3. I starts at 1. So while I is less than start intervals dot length, so 1 is less than 3, and end interval, which is 3 is less than ITV1, ITV1, end interval is less than ITV1. That makes sense. And end interval is greater than or equal to ITV0. Makes sense. Or end interval is greater than ITV0. Then the end interval is actually the secondary value, should be 6, otherwise it's the first value. So that is true for 2, 6. So end interval would equal 6 here, and I plus 1 would now be at index. We're just going to start doing this. I equals 2. So it was 0, 1, 2, right? So now we have output dot push 2, 6, but it's not right because we're returning 1, 2. So I must be doing something wrong. Let me follow the code more closely. I'm going to change ITV0. Let's just do it like this: 1 and 2. So if end interval, which is 3, interval is 3 less than ITV2. ITV2 would be 6. Yes. Is 2 greater than or equal to ITV1, which is 2? Yes. So we short circuit into here. Is end interval less than ITV2? 3 is less than 6. And end interval is greater than ITV1. 3 is greater than 2. We should get the value of ITV2. But instead, our output is 1, 2. That doesn't make any sense. Wait, why is I equal? Oh my god. So I comma 2. Oh, my brain is fried. My brain is actually fried. 1, 6, 8, 10. Why is it returning 2? End interval. If end interval is less, if end interval is greater than or equal to ITV2 and end ITV. Now, if it's greater than the first number or equal to it, and ITV is less than ITV2, then we should get ITV2 as the value. Otherwise, we should get ITV1, which would be 2. So let's just say we push let's just say it works and it goes to 1, 6. then we technically be at 8, 10. So then 2 would still be less than 3. Now is 6 less than 10 and greater than 8? No. Is 6 greater than 8? No. So we push 1, 2, which again makes no sense. I can tell I'm trolling now because I'm not even trying to figure out the code. I'm just something's wrong with my ternary in here, but it makes no sense though. It's either that if this is true in any capacity, then one of these two should change. Oh no. Yeah, it should actually never be the first number. This should just basically be ITV2. If I started at the 0th index, we should be able to start at 0 if I set this equal. If I add equals, maybe not the last one. No, scratch the whole equal thing. Since we're setting I equal to, wait, did I really add an equal to the intervals length? That was silly. I'm just gonna set it equal to 1. We'll start off by 1, and maybe this doesn't make sense because ideally you'd want to run the code one more time, so you have to start at 0. You just need to have some mechanism to ignore when things are exactly the same. So we'll just say if start ITV equals ITV1 and ITV2 if end ITV equals ITV2, then continue. That's actually bad because I'm running out of time. I should have did it. Making us continue forever because I'm doing it way too early. I mean, you could just do it like this. It's a little nutty because then the code is just harder to follow. Now I can definitely tell I'm trolling because if you start adding continues, it just becomes harder to follow. And I'm incrementing I in 3+ places, so it's like completely nutty. from intervals at length. We're still missing the last one. So we need to run the code for the last one, but I'm not exactly sure how you would make sure you still run it without not exactly certain. Yeah, I think at this point, I'm just gonna, you could do output dot push the last one in there, but what if the last one pushes the range even further? It doesn't make sense. Another thing you could do is you could have an inner loop that goes as far as it can. And that would not be best case time complexity, but at this point it is what it is. I'm just going to say m is equal to I, while I is less than intervals dot length m plus plus. We're going to move this forward, change this into an if. And then else, we're just going to break oops, I meant to do yeah, I think we just got to call it. I think the double while loop was onto something, but in the end I couldn't figure out the proper case, the off by one problem, so it just wasn't going to work out. If we draw a graph with intervals as node that contains, if we draw a graph with intervals as nodes that contain undirected edges between all pairs of intervals that overlap, the intervals in each connected component of the graph can converge into a single interval. As an adjacency list, inserting directed edges in both directions. Approach 2. I think the first approach is doing too much. Approach 2 sorting. If we sort the intervals by their start value, then each set of intervals that can be merged will appear as a contiguous run in the list. First we sort the list as described, then we insert the first interval. Sort the list as described, then we insert the first interval into our merge list and continue in considering each interval in turn as follows. If the current interval begins after the previous interval ends, then they do not overlap, and we can append the current interval to merged. So if the current interval, so let's say 1, 3 begins after the previous interval ends, or begins, then they do not overlap. The current interval begins after the previous interval ends and they do not overlap. Otherwise, they do overlap. Okay. Otherwise, we merge them by otherwise they do overlap, and we merge them by updating the end of the previous interval if it is less than the end of the current. Otherwise, they do overlap, and we merge them by updating the end of the previous interval if it is less than the end of the current end of the previous interval if it is less than the end of the right. So if 3 is less than 6. Simple proof by contradiction shows that this algorithm always produces the correct answer. The algorithm at some point fails to merge two intervals that should be merged. This would imply that there exists some triple indices I, J, and K in a list of intervals in such that I, J is less than K. Interesting. So it looks like if I make this wider, first they sort the intervals by the start of the interval, which means that all intervals that can be merged should appear as a contiguous run. If the list of merged intervals is empty, or if the current interval does not overlap with the previous. If the list of merged intervals is empty, or if the current interval does not overlap with the previous, so the current interval would be 0, 3, and it does not overlap with the previous, simply append it. So merge.getLast. So if 3 is less than 1, 3 is not less than 1. Otherwise, there is no overlap. So merged.getLast. So if merged is empty, then they just add the interval. So you add 0, 3. To merge the current and previous intervals. So merged.get. Otherwise, there is no overlap. So you merge the current and previous intervals. So merge.getLast. So current and previous intervals. Turn merged.toArray. Isn't it already? Oh, they're using a linked list for merged. I wonder why that is. The merged is an array for interval and intervals. If the list of merged intervals is empty, list of merged intervals is empty, or if the current interval does not overlap with the previous. So if it's empty, just add the interval, and if they don't overlap, otherwise there is overlap. So they get the last element merged. They merge the current and previous intervals. The complexity here is n log n because of the sort. Other than the sort invocation, we do a simpler linear scan list. The runtime is automated by the n log n complexity of the sorting. Space complexity is log n or O of n. If we can sort intervals in place, we do not need more than constant additional place. Space, although the sorting itself takes O log n space. Otherwise, you must allocate linear space to store a copy of interval and sort that. Interesting. I think I'm seeing that LC mediums are a completely different breed. I've been doing mostly easy problems, so mediums are different indeed. Well, I like the difficulty ramped up. It's kind of getting me excited about the future. Interesting. Arrays and sorting similar questions. I don't know if I'm necessarily understanding the intuition behind this problem. If you sort them, then the ones that are likely, I guess they never mentioned that they were sorted. The array of intervals could be in any order. It's just that the input they were given was sorted for the sake of the example. But my implementation would have failed anyway. Actually, no, it wouldn't have. I would have just had to sort it originally. I think our way of solving it, though, I don't know. The intuition behind this one makes more sense to me. But I think the way I was going about it is a little ghetto. But I think this one was one that was easier to follow. I think could work. Except I would just have to append a solution in mind where I actually sort it beforehand. While I is less than intervals dot length. I is less than intervals dot length. ITV1. I also think the other thing that really threw me for a loop on this problem, my variable names kept confusing. I was saying ITV1 and ITV2 and then ITV sub 0, ITV sub 1, end interval and start interval. It just got really confusing. So yeah, I think maybe this would have been easier if I S1, E1, and then we could say S2, E2, that way you know what you're comparing with what you're comparing. Mine's got so convoluted. So S2 and E2 will destructure it, right? And we'd have, while I is less than intervals dot length, yeah, the first part, I is less than intervals dot length, and E1 is less than E2. E1 is less, so if my first end is less than the second end, but my first end is greater than the second start, that makes sense. Or E1 is greater than S2, or my end is greater than S2. My end is greater than S2. My first end is greater than S2. All right, then it should have still been 6, so that makes sense. That makes sense. Then we would do I plus 1, taking us to 8, 10. So I would equal 2. I would now equal 3. O would equal 2 or 1, 6. And 3 is less than 4. So S1 would equal 8. And E1 would equal 10. And then I would now be equal to 4. Wait, if it's equal to 3, that doesn't make any sense. It would have been at 1, which means that I would have been 2. Let me try one last time. I'm going to try running this from an empty start. I equals 1. S1 equals 1. E1 equals 3. So while 1 is less than intervals at length, which is 4, 1 is less than 4, S2 and E2, S2 equals 2, and E2 equals 6. So while 1 is still less than 4, is E1 less than E2? Yes. Is E1 greater than or equal to S2? Yes, so E1 equals E2. Then I plus 1, so I now equals 2. Output dot push 1, 6. If I is less than intervals, so I is 2. 2 is still less than 4. So S1 now equals 2. No, yeah, S1 now equals 2. And E1 equals 6. And then I plus equal 1. So it's now 3. So we've got 0, 1, 2, 3. So we already skipped a bunch. Now I'm seeing there's a big problem here. Is a big problem here. We skipping crazy. We're going from once we do the thing, we're going like crazy. Yeah, I'm seeing this one could only work. This one only makes sense. This one only makes sense with basically not 2 whiles, but a double for loop. All right, I'm just not seeing how you could do this with 2 while loops, because we have to move forward to continue handling intervals. But at the same time, you move forward and you can't work on another interval again because you've already passed one. you go to index 3, 0, 1, 2, 3. Damn, I believe in this solution so much. It's hard to let go. Hard to let go. But it's not going to work out. The solution apparently that's the best is sorting. So intervals and sorts make sense, I guess. Intuition seems to be that we should sort the list by the interval start. In this case, we can check because the ones that would interval that we could overlap would be right next to each other. So we'd have 12 and 20, right? Then we have 19, and it just happens to be that they overlap there. 11 doesn't overlap with 12 and 20. We push it on. Complexity n log n. So if it's not merged, so that if the array is empty, or it overlaps, I think I see there's one takeaway with these off by one issues. What you could do is just, if you work with, instead of working one forward because you don't know what's coming, you can work one backward because you know you already have did some work. You can double check that you can overwrite. So if there's no merged items, if the merged is empty, then they simply add it, because in the else they're going to overwrite it if it does overlap. Or one of my problems that I was working forward and get into some funky business there. I think that's a wrap. Maybe we'll try this one again tomorrow, but yeah.